So for this problem, we're given a note, something that we're gonna be using for in order to solve this problem, and it's the coefficient of friction. So it says the coefficient of friction for rubber and dry asphalt is 0.9, and the coefficient for friction for rubber on wet asphalt is 0.45. So we're going to use one of these two for problem 5a, and then we're going to use another one for 5b. Okay, so problem 5 says a 1500 kilogram car heading west slams on brakes, and then what would the frictional force be to stop a car on a sunny day? Right, so it's sunny day. So which of the top two are we going to use for a sunny day? It's going to be dry asphalt. So it's going to be, it's going to be the top one. So we're going to be using 0.9, right? So our mu, let me go ahead and erase this. Our mu, it's going to be 0.9. 0.9. That's going to be our coefficient of friction, and that's what we're going to be using. So let's go ahead and look at our body diagram. So we have a car that weighs 1500 kilograms, and we know that there's going to be gravity pulling it down, and there's also going to be a normal force that is perpendicular to the surface. And then obviously the car is moving forward, and that's this force, and we're going to need a force to stop it, right, which is going to be the kinetic force, this one. So that it all depends on the asphalt, right? In this case it's sunny, so the coefficient is going to be 0.9. so we're going to be using this formula right here. It's mu equals the kinetic friction over the normal force. Okay, this is the formula we're going to be using to solve this. So let's go ahead and fill what we have. We know that we have mu, so mu is going to be 0.9 equals, and it's going to be the kinetic force, right? So we don't have the kinetic force, right? We don't have it. That's actually what we're looking for, the kinetic force, but we do have the normal force, right? Or we don't have it, we can figure it out, right? We know that, let me write it down below. We know that the normal force, it's equal to the force of gravity, which is weight, right? Our weight. So this force of gravity is m times a, right? So we know what the mass is. The mass of the car is 1500 kilograms. So let me go ahead and write 1500 kilograms times acceleration, which is 9.8 meters per second squared. Sorry, meters per second squared, and I forgot kilograms. So it's going to be kilograms times meters per second squared. Right, and we know what this becomes. This is simply just newtons. And let's see what 1500 times 9.8 is. So 1500 times 9.8 is 700. 700 newtons, right? So this is the force. This is the force, the normal force. Okay, so the normal force, we said it was going to be 14,700 newtons. Remember that mu, the coefficient of friction, is unitless. Okay, so the newtons is not going anywhere. So in order to solve for the top portion of this fraction, we have to reciprocate. We have to do the opposite of division, right? Because this is being divided. So we're going to multiply both sides by 14,700 newtons. Sorry, running out of space. Never mind. I was zoomed in. Alright, so 700 newtons. And then the same thing on this side. Let me clear out some of the space. So we said it's going to multiply times 14,700 newtons. And why do we do this? Why do we multiply both sides by this? So we can cancel these out, right? So now we have the force of the kinetic friction on one side by itself, and we can multiply 14,700 times 0.9. It's going to be 13,230. Right, so that's going to be my final answer. The force required to stop this moving vehicle, it's going to be 13,000. Oh, I forgot the unit. 13,230 newtons, right? Due to the dry asphalt, right? It's not going to be the same for water, right? But when it's wet. So hopefully this all made sense for you guys. And you guys are understanding it a little bit more.